Okay, in this video we're going to talk about the discriminant of a quadratic. Now a discriminant does two things. It classifies the type and how many roots or zeros a quadratic is going to have. Type meaning real, imaginary, rational, or irrational, and how many means you can obviously have either two answers, one answer, or no real because you're going to have two imaginary answers. And let's talk about the classification. When you use the discriminant formula, which is going to be b squared minus 4ac. When you use that formula, the number you generate from that formula gets classified into a certain category. We're going to talk about those four categories. If your discriminant number is greater than 0, that means positive, and a perfect square number like 1, 4, 9, 16, 25, or so on, then you're guaranteed to have two real rational zeros. Now that means pretty answers like whole numbers, fractions, decimals that repeat or terminate. Okay? If you use that formula and you get a discriminant that's greater than 0, positive, but not a perfect square number, so it's not 1, 4, 16, 25, or so on, you're still going to have two real, but they're not going to be rational, they're going to be irrational. That means they're not necessarily going to be nice, pretty whole numbers. They might have radicals in them or ugly decimals, long decimals. Okay? Using that formula, if you get a discriminant to be equal to 0, then you're guaranteed to have one real rational answer, and that rational answer is actually going to be your vertex, and you'll see that when you graph it. But the key here is to know it's going to be one real rational answer, so one pretty answer. Okay? And there's one more category. That next category is going to be, if you do your formula and you get your discriminant to be less than 0, that means a negative number. So if your discriminant is negative, then you're going to have 0 real solutions, but you're guaranteed to have two imaginary solutions. That means in your answer, you're going to have I. Okay? And we'll talk about what this looks like graphically as well. Let's do some examples. First example I have here. Negative 2n squared minus 3n minus 8 equals a negative 6. Now with quadratics, you always have to have that right side equal to 0. So I'm going to add that 6. Okay, I'm going to label my A, coefficient of n squared, my B is the coefficient of n, and my C is always the constant. Let's write our formula. B squared minus 4AC, that's our discriminant. We're just going to plug in, use some substitution. Anywhere there's a variable, a letter, we're just going to put some parentheses and plug the appropriate number in. So in place of B, that's negative 3. In place of A, that's negative 2. In place of C, that's negative 2. Then we can do some simple computation. And now if you struggle with basic computation, you can actually type this piece just like you see it into a calculator and it will generate an answer. I want to show some computation. Negative 3 squared is going to be 9. Negative and a negative is a positive, times a negative is going to be a negative. 4 times 2 is 8, times 2 is going to be 16. 9 minus 16 is going to be a negative 7. So my discriminant in this problem is going to be a negative 7. So if I go back and classify here, a negative number, if my discriminant is negative, that's right here, then I'm guaranteed that I have no real answers. I'm going to have two imaginary answers. So I would label here two imaginary zeros or roots. Now what does that look like graphically? Well, graphically that simply means if you don't have any roots or x-intercepts or zeros, that your quadratic won't touch the x-axis. Now let's do a couple different things here. Here's my quadratic. The A value is negative, so I know it's going to be concave down, but I know I have two imaginary answers, so I won't touch the x-axis. So my quadratic is going to look something probably like that. Okay? And we'll talk more about how to find those actual solutions in the next video called Quadratic Formula. Next example. M squared plus 4m plus 6 equals 2. Get it equal to 0, so subtract 2. To get m squared plus 4m plus 4. Label your A, B, and C. A, B, See, don't get confused here on the m squared. There's always a coefficient of 1 if nothing's written there. So your a happens to be a 1. Okay? Now, your formula, b squared minus 4 times a times c. Always put your parentheses as placeholders and plug in some numbers here. So in place of b, 4. In place of a, 1. In place of c, 4. Again, you could type this in the calculator or just do some simple math. 4 squared, 16. A negative times a positive is still negative. 4 times 1 is 4, times 4 is 16. And 16 minus 16, well, that's going to be a 0. So if we go way back to our first screen to classify, if our discriminant equals 0, then we are guaranteed one real rational answer, and it happens to be our vertex. So let's go back. Let's label one real rational. Let's think about what a picture would look like. So what would a graph look like? Well, my a value is positive, so it's concave up. One real rational means I'm only going to touch the x-axis one time. So it may look something like that. This vertex right there, that's where your rational root would be. Let's do one more example. Subtract 3 from both sides to get 4x squared plus 5x minus 9 equals 0. Label. Write your formula down. Use your parentheses. Let's just plug in what we know. B is 5. A is 4. C is a negative 9. Again, type this in the calculator or do some simple math here. 5 squared is 25. Negative times a negative is a positive. 4 times 4 is 16. Times 9 is going to end up to be 144. And do some math here. 25 plus 144 is going to be 169. So, looking at this, let's classify. Do it without the screen if you can. If you can't, you can go back to your notes at the beginning of the video. 169 is perfect and it's positive. So a perfect positive is going to be 2 real rational. What does that look like graphically? Are you going to touch the x-axis twice? That happens to be 2 very nice, pretty numbers. Positive a value means concave up, so it may look something like that. Okay? One last example. Subtract your 6 from both sides to get 7n squared plus 6n minus 3 equal to 0. Label. Formula. Plug in your appropriate values. In place of B is 6. In place of A is 7. And C is negative 3. Do some math here. So 36. 2 negatives make a positive. 4 times 7 times 3 should come out to be 84. Just checking my math here just to be sure. And then you add up 36 and 84, you're going to get 120. Perfect square? No, it's not a perfect square, but it is positive. So we know we're going to have 2 real. The perfect square one gave me rational, pretty answers. So the not perfect square one is going to give me irrational. Again, what does that mean? That just means that your quadratic is going to have maybe ugly decimals for answers or radicals in their answer. Graphically, what would that look like? Well, again, it's still going to touch the x-axis at 2 places. Your a value is positive, so still concave up. So possibly something like that as well. Okay, so go back and study your discriminant notes and make sure you know the difference in your 4 categories before you do some problems.